so I'll cross my fingers. It's an honor to be up here on Iceland for the first time in my life, but hopefully not the last time. So I will come back. This presentation will guide you through some hot topics for the moment. It's about the small collaborative robot. You might have heard about it. And then we'll go through also some nice TIG attack. It can be done manually or it can be done together with this robot or cobot, as we call it. And then I'll end up a bit about the calculation and a small speech about how to collect data. I know we have been through it, so I will briefly come around it. Who said something about DSL? I'll end up with a 2-minute speech about DSL, the Danish Welding Society. So don't worry. Yes, we are located in the northern part of Jutland in Denmark, and I would say if you haven't been there, this is an open invitation for you. So you are very welcome to visit us, individual or as a group or whatever. Just give us a ring one day before so we know that you are coming. But you should absolutely be welcome up here. We are established in beginning of the 70s. We have a production platform here in Fjerritslev for all the European markets, and then we also do machines in India and in Chennai for the Indian market, and in Suzhou, a bit west from Shanghai, for the Chinese markets. And I have been product manager for Mechatronic for 20 years now, and before that I was in Lincoln in Denmark, so you might have heard about also Lincoln. They are from over there. Yeah, and Iceland is just up here. It's just a few hours away in an aeroplane, so don't worry. Looking into this automated solutions, then sales of robots is just going up, 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 and up. And the increase has been incredible on some markets. For instance, in China, 31% from 16 to 17, 31%. And then follows Korea, Japan, United States, and then Germany in Europe. So it's really going up, and that's also due to the car industry. It has a big influence. I was really searching before getting here in figures from Iceland. I couldn't find it, but these are the figures from Denmark, and it's in 17 it will be nearly 800 different robots, and most of them are not for welding. They are for handling and painting and stuff like that. But approximately 20% goes for a kind of welding. It could be arc welding, or it could be some other kind of welding. It could be resistance welding for most also, but different kinds of welding, approximately 20%. But as you see, the Asian market, and as you said from Isa, when we optimize something, then in China they are not going because of the salary maybe, but the uniform quality, because they export also a lot. So the requirements from Europe are relatively high, so that could be one of the reasons also. Yes. And this is the sale. Of course, we have a drop here when the crisis were on, but it's going up. And these are the figures for robots in work, in daily work. It's approximately 5,000-6,000 in Denmark. I don't know, do you have any figures for Iceland? No statistics? No. Maybe we should have a tour and count. Yeah, there must be some.
5 or 7.
Yeah.
That would be a quick tour.
That's nice. Should we go clockwise or counterclockwise? The newest figures tells that 44% of Danish companies that has more than 10 employees, they have a robot for something. more than 44%. That's a lot. And it's typically companies that are going up and becoming more and more popular. So absolutely. And I went before the summer holiday to a school semester in Denmark at Vingsted. And a lot of schools, they are also in competition with each other because they want to be attractive to students, come to my school and so on. So they are also grabbing more and more robots into their teaching. So that's also a trend we see. Yeah, we are doing ordinary robots from Fanuc, ABB or Yaskawa or whatever, but these small universal robots, they have really come to the market, we must say. More than 24,000 robots has been sold over the last 10 years, and it's going up and up. One thing which is very important here is that the price for such one is maybe half or less compared to an ordinary industrial heavy robot. It can do most of it, but it cannot do everything. So it has also some limitations. We'll come back to that. But one thing is important, that within less than 200 days, the payback has been there. Less than 200 days. Then that's very good for such a relatively high investment. Less than 200 days. And when it's universal, it's a part of this tool, you can say. People think, oh, it's a robot, and it is a robot, but it's also more or less a kind of tool. So it's another way of seeing such a small robot or cobot, because it's in collaboration with a man or a machine or whatever. That's the name cobot. That's where it's coming from. Minimum complexity. Nobody wants to read a very big manual, so it must be intuitive in the way it works, and it is. It can carry out routine tasks. If you are doing the same and same, and next month you're going to do the same again, then you can just recall the program and it's ready. It gives improved competitive power. If you are going to buy such one and you are into a tender or an offer, you should then, okay, you can do this for 1,000, but your neighbor can do it for 950. And if the specifications is the same, then the one that can do it for 950, he'll get the order. So it's important to get the price down for each piece you manufacture. That is really the way to be competitive if the specs are the same. We have a hybrid solution because we combine it with something. It could be a human, or it could be a machine, a welding machine, or it could be something to pick and place or whatever. Optimized work environment. I'm sure that the dust and the light and the heat and the bad positions will kill people during a lifetime. You'll be tired when you are 60 or older. But having this one, if it's Monday morning or Friday evening, it doesn't matter. It's absolutely the same quality you put out at the end. So that's important to understand. It could eliminate bottlenecks in the company if, of course, welding in this case are the bottleneck. But, of course, if it's some other processes there, you should, of course, optimize there also. It's not just to put in a robot and then everything will go well. If the preparation of plates and pipes are not for robots, then of course it will not help to make a robot. You can say the quality of the prefab should absolutely be uniform, because the robot is more or less stupid. So it will do the same, so the quality of plates and so on should be more or less the same every time. And then it's a mega trend. Yeah, that's a buzzword, you can say, but I think it's difficult to go against these mega trends. We have a lot of mega trends. People move from land to cities, the urban. We know people are getting older. The economy flows more to east. There are stuff like that. Internet of Things. That is some of the mega trends. We can't go against it. We can maybe be passive, but I'm sure they will catch us at the end. There are some limits, you can say. You can't get as much extra equipment as you can for a very expensive robot. There are also some limitations in the size that you can weld, the width. But then, of course, you can move the robot on a sledge or something like that. Then it can overcome the size. But there are 2 models, and they have different sizes. That's more or less the difference between the robots. It's a UR5 that can carry 5 kilogram, and then you have the UR10 that can carry 10 kilogram at the end of the arm. And then it's a bit bigger. Reduced speed, and in this case it's a benefit, because then you can operate together with this one without having the fence or the light protection or something like that, because as soon as it hits something, it stops. So due to safety, and the reason for that, it can be CE approved and CE labeled, is that it stops immediately as soon as it touches something. So that's put in the software, how big pressure should it meet before it stops. More than 80% of all solutions, they are working without any fence. Of course, if it has a very dangerous tool, you can say, at the end of the arm, then it could harm people, of course. So in these cases, there could be some tools that requires that you are some centimeters away from where the end could be. But in most cases, everything works without any fence protection. Reduced speed, that is not when you are welding, you say, oh, I could like to weld a bit faster. That is not there. It's the idle, when it moves from A to B in free air. That is where it is limited in speed. But not welding. You can weld meters per minute without any problems. This is in Danish. It's also in English, of course, but it's very easy step by step. And most people, they are getting started with simple structures within hours. So that really tells that it's easy, because if you have an ordinary robot, it could be long-haired, as we say, to understand it. But they have really found something here, because it's much, much easier to program step by step. And we have made some special menus for welding, if it's circular, it's a triangle or whatever. So you just change some data, and then you have the new setup, you can say. So it's very easy to manipulate. It gives really good ideas here how it works. When it's for schools, you can say the eyes from a school is maybe different from the eyes from the industry. So it depends, but it also have an overlap. And you can say in schools today, you have more open workshops. In the past, you know, when you went to school, okay, next week I'm going to do this and that. But nowadays, you have one student there doing this, and you are doing MAC, and he is doing TIG and MMA and plasma and whatever. They change all the time, so it's difficult for teachers to get them gathered and say, okay, next week we are going to do this and that, because they are not that homogeneous. And we also see, but also in the industry, that this one, because it's portable, you just take it with a forklift, or 2 men can carry it, then you can move it to different departments. Maybe you want to weld, the other want to paint, or the third one wants to grip something from A to B. So you can share such a robot because it's mobile. Yeah, and as you say, when students went out from schools, they go into the industry where they see the robot. So why shouldn't they have seen it on a school, for instance? So they are prepared for the next job is coming there. In the industry, we see a high mix and low volume. So people change the different tasks a lot of times. So it's important that you can store the settings and you can move it to another kind of job. And that means also that we see a lot of times that the fixtures they have been using for manual welding, they can easily be used here also. Because what you do, you just release, there's a knob on the robot, you just press and release, and then you just position it where you want, and you say, okay, here A, and then you release it, go to B, plug it in, you change the torch angle, whatever, and then it put in the lines to follow. So it's very easy in that way. And I would say we know for sure it's difficult to get well-skilled welders. So it's easier to get an operator to do this. So what we often see is that a skilled man in welding, he do the procedure, he do the programming, and then you put an operator just to push the green button and move articles and so on. So you don't need that high skill. And just if something is going wrong, he can say, okay, come and look what's now we have this and that. But you don't need necessarily to have a very skilled welder during the daily work. Then he can be released for something else. We also have some cases where we have a laser cutter or something, and then you start the laser cutter, it takes 20 minutes to damage the plate, you can say, and then in the meantime he can do something else. He's just standing there, have a smoke or whatever. It's not allowed due to the paragraph 17, but that's another thing. But then he can also do something else in the meantime. That's also seen out there. And what could be common? You can use very simple fixtures. It's an open cell. It doesn't take up that much space. And you can say improve competitive edge on all parameters. And here was what I said, the 44%, and that's high. And it's a safe robot cell, no safety fencing. And you can do offline programming, very easy. You can also have what we call a PC splitter. That means that if you want to teach your people, then you can connect it to the computer, and then you can put it up on the screen, or you can separate it to computers, whatever. So more than one student can learn from it immediately. And also for smoke and so on, it's easier to remove when it's placed. What we supply, if we are talking Mic-Mac, in a way, that is a complete solution. Just to plug in, the only thing you need, more or less, is the gas cylinder, and then you're ready. And this can be handled by a forklift, or you can lift it. You see the small one without the fence has a weight of 18 kilograms, and the bigger one has a weight of nearly 30 kilograms. So it's a light robot. The radius 850 millimeter and 1300 for the bigger one. So it's mostly the bigger one we sell. TIG will just under CE approval is just ongoing for the moment. So it will be released in 1 or 2 months. So that could be ordinary TIG, or it could be with a kind of cold wire feeder if you need that. That's up to you. But both solutions will be ready. Yeah. I think the number of demos that are in the book is incredible. It's 3-figured in Norway and Sweden, so people are really going into it. So a lot of possibilities with this one. And I would say when people they get such one in, then they automatically start thinking, what else can this one do? What other jobs are we doing? And we are also doing it at Mechatronic with this one. And I say sometimes we do cabinets only, maybe private labeling or something, only maybe 25 at a time. And then we put it into this station because it's very easy to set up to new tasks. And then they have this Sigmund table, you know, and you have maybe some plates with a fixture. So you say this is for doing teapots and this is for something. And then you have the plates on the shelf. You just take it and place it on this Sigmund table or whatever, and then you're ready. Yeah, different accessories, and there are much more. A lot of different. It could be vacuum. It could be pick and place, it could be for painting, it could be for looking where are the items on the table or something like that. It can be more and more sophisticated.
Does it, does it endure any water? Can you use it like in
On a
there's
plasma,
a lot of cooling, splashing or things like that?
yeah, you can protect it. You can. You can't put it underneath water.
Okay.
That's for sure. So for dry environment, normally, yes. Yeah, you can say you can protect it in different ways.
Yeah.
So I'm sure that it will be possible to make a waterproof protection. But as it is, don't put it underwater.
Okay.
If there are more questions, I have brought the card from the world of sport. So, but this was a good question. Don't worry, just be seated. Yeah. On the home page, you can take software for free. You can play with it, see if it's something that I can do or whatever. So there's a lot of videos to get started also with this one. And it could be an eye-opener for a lot of people. I don't know if it was easy, but hopefully it gives you an idea of what such a cobot can bring. Yeah.
Maybe I get the red one. Torben, one question about the CE thematics. Because we're working also in this field,
Yeah.
and I'm a really big fan about these small systems with universal robots. Yeah? We've done something else as well. But how do the customer, the end customer, the end users getting this CE declaration for this total system?
They get a document. You can say, even though that we take CE approved different articles and put together, then it's a complete new solution. So due to the regulative for installations, then it's a brand new one. So it's not approved, even though that the Lego blocks, you can say, are CE approved. So it's very important. It goes to the institute, and they control it also in combination. What kind of tool is it? The robot has at the sharp end. And what is the speed for it, and when will it release for when it's knock-proof and so on. So all these things are a part of this. So you can say as soon as you change something with a CE mark, then it's not CE labeled anymore. Normally, we know for sure it goes out there, it works. But you can say one day if something happened, then the guy with a hat is coming, then I'm sure it's nice to show the document. Then you can do a bit like that. So
Exactly, because everyone sees here this is really a good solution. But what about the end of the torch, the wire? You have a steel wire on the end, and it's moving into an eye, for example.
yeah, I agree, and that's also what could be dangerous, you can say. Most people, they also have maybe they do a turntable, or they have a fence. They put in parts, and it's welding on the other side. So already there, you normally keep a distance to the robot, and then you turn it, and then it welds on the backside, and you take the welded items away again. And then also you can say our welding machines, and maybe some others, of course, if they don't get the arc on, then immediately the machine will stop. So if it starts feeding the wire without registering that the arc is there, then it stops also for safety reasons. We also know for sure that a long wire coming and touch the item, then it will become red, and it could start a fire and so on. So there are safety systems that should play together. Yeah.
Because we are also looking at the safety side. We need some perimeter when the robot is operating. We need some perimeter because if some human interference is going in, then it has to stop immediately. So we are looking at that.
Yeah, that's normally for an ordinary robot. But this, you can say, this collision insurance is in the robot. As soon as it meets some resistance higher than it is adjusted to, then it stops immediately. And that's also why the idle speed is relatively low. It's not just, why is it not going there? but it's not that fast as you see in a Fanuc or whatever.
But my question is, how many axes you can go in?
6.
6 axes.
Yeah.
Because we have seen some lot of robots like Puka. When it goes for when you operate a wire, when it goes for a corner joint,
Yeah.
we always find a defect. And then people say that it's the teaching method one in the US of the movie. It has some effect on that.
Such a robot is yeah.
Solved now or
Yeah, you can say it's when you do the programming, then you need to reduce and accelerate the speed when it's turning around corners. So a robot is working in sequences. So you put sequences in and the weld data. So the robot just pick up sequences from the welding machine, and then you can limit the speed in the corner as well. Yes.
because we have a lot of people are qualified and they are trained in that corner, and we are focusing more on the furniture.
Yeah, also, but that's also seen in manual welding, because that you have you might come for a 2 or 3 dimensional heat zone, you can say, where you can release the heat from. So it changes when you get to a corner.
Yeah.
So that's also
So then it is good.
it is, and also TIG. We have also seen some selling TIG. And if you have asked UR robot, they say don't go for TIG because this high frequency could disturb the software. And in the beginning, some put TIG into it and they were damaged. And then you are standing with a remote of a certain thousands and just throw it away, and they say no, it has been used for TIG. But the new ones, which we are CE marking, they are approved for TIG and they are protected for TIG. All the knees and so on, they are protected for EMC noise also and high frequency. So they are better protected than the new ones, and they are allowed to use for TIG. And I'm sure that plasma could be next or whatever. Yes, a TIG attack, I know some of you at least have heard about it. It's still popular. You know for sure that when people are saying, what is new, what is new, what is new, we very soon and forget what was very new last year, the year before, because a lot of people, they haven't heard about it. So this is really where you can save time. Instead of doing ordinary TIG, you can say tack welding in austenitic stainless steel when you are welding TIG, then you can use this TIG attack. It's a high energy in very short time, and I'll go through it. And it's only for TIG, and it's only, you can say, developed for austenitic stainless steel, because you can weld it or meld it together without filler material a lot of time, at least when you do this. When you go for other materials, it immediately requires filler material in order to stabilize the arc and to avoid cracks and so on. So we say it's for austenitic, and don't worry, you can say that more than 80% of, I'm sure, what you are welding up here in stainless will be austenitic stainless steel when it comes to stainless. I'll come back to that. Some of the trends we see is that, and that is for TIG and that is also for MIG-MAG, what will be the next? And we know for sure that documentation, etc., will grow. But what was a bit easier in the past was that the world was more linear. And that means that we see a market will grow some percentages and we could predict it more or less. That was okay. But then it really accelerates. So the megatrends will not be there for that many years as they were in the past. So what we see now here is that it's more exponential, and that means that we can only predict it for a short time. So what we see and think will be popular in 3 years, it's maybe not popular anymore at that time. Then some other and extras has taken over. And that is important, that we do not fall asleep. But we can't rely on that what is popular today will also be next year. So we had to be aware of that the world is more exponential. When we go to TIG, in general, you can say the TIG process is very tolerant compared to MIG-MAG. If you go micmac, then you can say a certain wire feed speed will require a certain voltage. And you have to be in this operating window, you can say, because otherwise the process will not work. You'll create a lot of spatter. But in TIG, it's a very tolerant. You can go pulse welding from 5 amp to 400. It's not that useful, but the process will work. So that's the reason for a lot of TIG machines. They are as they have been for years. So the new stuff in TIG will absolutely be in the software. It will be less noise when we do pulse welding, when we change from high to low. It will be easier to operate. That means more synergic lines in a TIG and stuff like that. Especially the noise level is very important. We also see more different and difficult gases, gas mixes that are more difficult to ignite, to start. And that means that the high frequency, the way it is made, should adapt these new gas combinations, especially if you have long hoses up to maybe 20 or 25 meters sometimes. With a difficult gas, pure argon is very easy, but as soon as you put a lot of helium or maybe some hydrogen into the gas, then it becomes more difficult. So it requires more and more of the machines in that direction. Plug and play up against interfaces will also be more and more, because these robots, they are not good at speaking the same control language, you can say. So interfaces that are more or less comparable to Google translation, you can say. The machines has one language, but all the other devices, they go for Ethernet, EtherCAT, Profibus, etc., etc. So we need to be able to do a lot of plug and play when it comes to interfaces. And at the end of the life cycles, it's important that we can scrap it in a good way. And it's also, we must stick to more and more documentation. And I'll come back to documentation. These TIG attacks are these small spots here. And you see, I'm tightened here, so I can't go over there. But there are some welded plates. They are fixated, because if we say it's an ordinary tack, then you can go into the norm and see, okay, a tack, it should be like this, and due to the plate thickness, the length should be blah, blah, EN 1011 or something like that. But when we do a fixation, we put an amperage that are 2 to 3 times higher than you normally will do the complete weld. But we only do it in milliseconds. And that means it's for eye grooves, or you can say a butt weld. You can put them into 2 if you want, but if you try to maybe bend it a bit, then you can look into the groove and see that it's very shiny. And that is the most important. And that is because there's a phenomena called anodic stripping. It's not stripping as you might think it is, but anodic stripping, and that means that we can't purge new oxygen because it goes that fast. So we will not purge with this oxygen, and that is what harms the backside of stainless steel. I have done this more or less ordinary tack welding, and when you are on distance and your eyes is not that good, then it looks okay. But as soon, you know, as you take the picture and pull it in the corners, then you see, oh, it's maybe not that nice. But as soon as you do the TIG attack, then you have a very shiny surface because you have the gas protection from the front, but we don't need protection gas from the root side because it goes that fast. And that is really the key. All these testings has been done together with this company Damstal, as you might saw. And afterwards I have some leaflets here. And what the clever guys down there say is that has been in Arla and traveling around, they say when people are going to do such a diary or whatever in stainless, then about 20% of all welders, they do the tack welding without having the proper gas protection from the root side. Sometimes it goes, especially when the diameter of the material is high, but when it's thin, even a very good welder thinking is very quickly, but a lot of times you will harm the backside. Absolutely, it will be too dark, it will be too coxed, you know, you have a lot of like scales, you can say, but too dark on the backside, and then you have the problem. Then people say, okay, when we put protection gas and we do the complete weld, then it disappears, but it doesn't. You have harmed it, and when the diary is there, you'll see no problems for the next month, no problem, but suddenly after half or 1 year, then the listeria figures goes up and maybe corrosion as well, and then you have a shutdown on such a diary, and that really costs. So, what's going on? It's on my computer, it looks nice, but what we're showing is just that as soon as you can remove the torch, or the robot can do, as soon you can do these small spots in milliseconds. So it's very, very easy to carry out such a TIG attack. Important is that you don't have any air between the surfaces, so they should be put together, because we do it without filler material. So we can't take materials from one side to another if you have a gap. So it's important that you just put them together in the eye groove. If you have a groove with air, then you need to do it in the ordinary way, and then include protection gas, of course. It was a nice video, I saw it. If you do an ordinary tack, then you will harm the plate more. And doing this, you'll just have a small this lens on the top of this. You'll have less deformation, you'll have less coloring of the plate. One thing which is very good also for doing weld in general for the austenitic is that you can add what will be clever to add in pure argon. What kind of gas mix could be very nice to get a more shiny surface and to get a faster weld. What could be nice to add? 2-3% of hydrogen. That is very, very good. You'll immediately see an increase of speed for maybe 20-30% and a more shiny surface, and you can start welding before, because it starts floating a bit before. So it's very, very nice to do it. Yeah, there is a form where you can see, okay, it's tridimensional. You have the amperage, you have the plate thickness, and you have the time to set on the MMI on the machine. And as soon as you are in the green field, then it used to be okay. You must also, before you start, ask the guy who is in charge for this, is it okay we're using this? And then you do some samples and you keep the samples, because then you can repeat them and say, okay, if we can say go for this, then we use this, and we can save a lot of times and reduce the risk. A lot of companies in Denmark doing diaries, etc. in stainless, they're using this TIG attack for clamping all the pipes before welding. The most important is, and Vagn, you also know, is to keep a low temperature, because as soon as you exceed 250 and so on, then the oxygen will immediately grab to the heated plate. So it's important to keep a low temperature on the backside, where it's not gas protected. So we have done a lot of tests in this, of course. Are we on time? Thank you.
5 minutes.
5 minutes. That was very fast. Now we go to speak a bit about the heat input. It has been really a hot topic, how to calculate the heat input, especially on the new modified arcs. Because you can say in the past we have this formula where we can calculate the heat input into the plates, but some very clever people, they say, okay, but the new modified arcs, which I think most manufacturers of welding machines, they have of today is because they want to weld without spatter. How fast can we weld this 1 meter? That is the key parameters. And then we have developed different types of arcs, but we more or less want to obtain the same, but we do it in different ways. It has also different names how we do it, and I'll come back to why it's there. Ordinary short arc has, you can say in general, a risk of spatter that's built in the process more or less. We have to refine it, we have to do something. And then you can say years back, then pulse was invented, and you can say pulse is normally used in the field for the amperage area where we normally will do short arc welding. As soon as we go to spray arc welding, then we don't need pulse more or less, because then we have no spatter, and then we obtain more speed by doing spray arc compared to ordinary pulse welding. So we want to do something in the short arc area. That's normally what we want to do. Due to the norms, this ISO 463 here also, and the 18491/2015, there are two ways to calculate heat input in general, and that is the average of the complete weld, as we always have done, but then all the new modified arcs has arisen. And why can't we grab them with this one? Then we need another way of calculating, and that is instantaneous. That means what is the heat input right now. So we need to go specifically for the heat input right now, because the frequency in the arc is much higher than it is with ordinary short arc or spray arc welding. And of course, if we can optimize the way of calculating, then of course it would be stupid not to adapt it. But we must also be aware of that in practical welding out there, in the real life, then the quality of the weld depends on a lot of things. It's about the gas, the stick out, the temperature, and the time we are on high temperature, the power source, process mode, and everything. So if we say that the average calculation is the yellow one, and then we go to the new one, then it becomes immediately a bit academic. But as soon as you can make a formula and put it black on white, then people believe in it. But we still must be aware of that all the other parts has a lot of influence. And as soon as we can calculate, then the Excel sheet will win, and we have to be aware of that also. But what really happens is, this is a comparison between old and new method. And depending on how you calculate, the machine can do it for us and for somebody else, but when the guy with the cap is coming with his multimeter or a clamp meter or whatever, then it requires very expensive equipment, because an ordinary clamp meter cannot grab these peaks that are there 200, 300, 400 times per second. That cannot be done with such an ordinary cheap equipment. And it gives a difference in heat input between, we could measure between 0 and up to 40% of the result, depending on which method you calculate. And that is because if you could imagine that an ordinary equipment will measure sometimes per second, then you will not get the complete peak measured. So you can imagine if you measure here, okay, the average current and heat put to the plate is relatively low. But as soon as you require in the norm that you should be capable to measure minimum 10 times per wave, per cyclus in the arc, then you can imagine, and then you will get a more precise measurement, because then you really grab also the peaks that are only there for milliseconds. So that gives the difference. The weld is the same as you did yesterday, but maybe if you are doing a new procedure today, then you will exceed the heat input by calculating the other way. So that is where the academic PowerPoint comes, you can say. What we could wish could be that there will be a harmonized standard for manufacturers of welding machines that could define how often should we measure. We measure a lot of times in order to control the arc, but in order to read out the heat input, that is different, and that is different from manufacturer to manufacturer, because the number of peaks in the way we have made the arc is different. So just saying the equipment should measure minimum 10 times per wave, yes, but what is the frequency in the arc? Nobody knows. So that should be harmonized in the future. That could be nice if we could agree upon that. When we have done this weld, we carry out data from the weld, and data is very hot for the moment. Everyone is yelling for data and Wi-Fi, and it's really buzzwords, but we have to transform these buzzwords into some bizwords, something we can use in business that is useful. I think sometimes it's like, you know, when the dog is running and trying to catch the cat. It's very funny to do this, but as soon as it grabs the cat, it doesn't know what to do with the cat. And that is sometimes the same with data. We asking for data, but what should it be used for? And when we interview companies around, for some it's pain in the ass and just an extra layer that costs something. For others, the more engineered they are, they really want data, and they do curves and they can do everything. So it really depends. Some others, they just want a big green lamp lighting up when everything is okay, and a yellow and a red one when something is going wrong. They don't want all the data. And when you have carried out a lot of welds and you have some mistakes, okay, where is this specific weld on the construction? Maybe you have burned a hole and then you need to start again, and the machine think, okay, now we are going in this way here. So it could sometimes be difficult with the data. But it's there, and there will only be more. But we have to be aware of what we are asking for. But we collect all the data needed, and also you can say how much wire, how much gas have we used, etc. Also, if you are saying I'm going to weld 2,000 of this and I'm doing an offer, then you can calculate and say, okay, then the time being per piece could be 20 seconds. I need 25 spools of this very expensive Inconel wire, etc. So you can also use it when you want to calculate and be into a tender, maybe. So we can grab all these data. And in high speed, the absolutely last thing, I'm at the board at this Danish Welding Society, and we have a small offer for you if you want. I have brought some of the last magazines that are for free. They are in Danish, but I know some of you at least understand it, so please take them. I'm not going to bring them back. But if you want to be a member, it starts at 400 Danish per year. Then you get the rest of this year and the year after. And in the next magazine, there is a lot about this 3D printing. And the biggest construction I have seen so far is a bridge made in Holland that is more than 12 meters long, made out of stainless steel, more than 4,500 kilograms. And that's really a big construction. And I think it's a bit strange when you say printing. In a way, I would say, okay, it's three-dimensional, but it's welding on welding on welding. It's wire, 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 wire. But that is called printing. I think it's more welding, but so is life. This is from the Hot Blue Lagoon, and this is an MMA electrode on holiday. So thanks for now. That was what I have to do.
Are there any questions?
Oh.